Okay, everybody, for the last part of this module, we're going to be working on simple interest, and that's what this worksheet deals with. In the next module, we're going to move into compound interest, which is a little bit more complicated, but this is pretty straightforward and simple. As long as you know the interest formula and understand how it works, I've written it at the top. Interest is equal to principal, which is just the amount of the loan, times the rate assigned times time. The time you have to pay back the loan. Now, one important note is time is always measured in years, okay? And if you have a loan which will work a problem that way that is shorter than a year, then you have to break it down into what part of a year it is and convert that to a decimal so you can use it in your equation, but we can work on that together, okay? I'll show you how to do that. Okay, this first one is very simple. It says a borrower takes out a $4,500 loan at 6% simple interest for 3 years. And we need the total interest that is going to be owed on this $4,500. And we already know that interest equals principal times rate times time. Okay, so in this case, interest is equal to the $4,500 principal times the 6% interest. Don't forget to move your decimal for 3 years, okay? So then you're just going to go to your calculator, and you have 4,500 times 0.06 times 3, and you get 810. So the total interest that will be paid on this $4,500 by the time you pay it back in 3 years at 6% interest is $810. And now it wants us to find the maturity value of the loan. And maturity value is just equal to principal plus interest. All maturity value is exactly how much did you end up paying back on this loan you took out. So all you have to do is take your principal and add the interest you found in step 1, and you see that the maturity value of this loan is $5,310, okay? So see, that's pretty easy stuff as long as you have the formula. Now, this one is just a tiny bit more complicated because it's not a full year. It's an 8-month loan. We still have our principal that works the same and our rate, but how do we figure out what to use in our formula here? All you do is you make a fraction, and 12 is going to be at the bottom if you're dealing with months, because how many months in a year? 8. And so 8/12. Now you can reduce that if you want to, but really you just need to divide it out, treat it like a division problem, and you're going to get 0.6666666666666 till finally it becomes a 7. So we're going to say for your time you're going to use 0.67. Okay, so that is your time factor in years, 0.67. So now we find our interest just the same way. It's equal to our principal, which is $2,800, times 0.09, which is our interest, times 0.67, which is our time factor. So 2,800 times 0.09 times 0.67 is equal to $168.84. That's the interest. And again, they want the maturity value. We're just going to add our principal to that interest, and we're going to get $2,968.84. Okay? That's how you do that. That's how you get that into a factor that you can deal with in your formula. The thing to be very careful with is don't multiply that by 8, because that's going to give you the interest you would pay if the loan was for 8 years. So just remind yourself constantly that time for interest has to be factored in years. Okay, now we're going to look at something a little different. We're going to look at exact versus ordinary interest. And you're mostly going to see this difference come up if a loan is in a really small time frame. Like, see, this is 120 days is the only amount of time they have to pay back this loan. And there's 2 ways that banks will do this. The exact interest method uses the exact number of days in a year, which is 365. This method is used by government agencies. The Federal Reserve uses it, most credit unions, okay? Ordinary interest is considered the banker's rule, and it uses a 360-day year. And you may think, why in the world would they do that? Well, they have been doing that since pre-calculator, and 360 was just easier to use than 365 because those nice round numbers that end with zero are just easier for us in mathematical problems. So most banks and other lending institutions, they still use this method. And part of the reason they stuck with it used to be simpler. Now that you're using a calculator or a computer, more likely it doesn't matter, but it tends to yield a higher amount of interest. And we'll look at that, okay? But the formula is very simple. Your principal is, of course, going to look the same. We know we've got $5,200. Your rate, you're going to multiply when you move this twice by 0.075, okay? And here's what you do. For exact interest, you divide 120 by 365. You divide the number of days in your loan by the number of days of whichever method you're using. So for exact, it's 365. And you get some craziness. You see, you get 3, 2, 8, 7, and it goes on and on. But the next one is, so we're going to round that up. We're just going to leave it at 4 digits so you don't just get overwhelmed by that. And so we will multiply these out. So this makes this your time. And if we take $5,200 times 0.075 times 0.3288, the interest generated is $128.23. Okay? Now, your principal and your rate are going to be exactly the same when we use the ordinary method, but we're going to divide 120 by 360 days, okay? So we have 120 divided by 360, and that gives us 0.333 repeating, okay? So we'll type out 4 because we did it over here. And let's see what we come up with. We have $5,200 times 0.075 times 0.3333 equals $129.99. Okay, and so you see why they like to use ordinary interest method. And that's not a lot of difference. If you subtract those two out, you're going to get $1.67. Not a big deal. But if you think about all the 120-day loans a bank might make in 1 year, this small amount of extra interest could really start to add up over time. And that is a big reason why they use the ordinary interest method, because you won't really notice this or care if you pay extra $1.67. But when they're multiplying it by all the people paying them back an extra $1.67, it can really add up for the bank. Okay. Now, the last thing we're going to do is find maturity date. And maturity date is just a fancy way of saying the due date. It is the date that the loan is due. You either have to pay it or renew it by that date. And this is very simple. It's a lot like finding dates on invoices. You just have to know how many days are in each month, okay? So you have a loan issued on March 18th for 75 days. Okay, so you start with the loan date, and then you just kind of count forward on the calendar. But you have to exclude the loan date and include the final date. So really the easiest thing to do is know that, okay, there's 31 days in March. So minus 18. So you have 31 days in March, and you started on the 18th. So there's 13 days taken up in March. So you have 75 days to cover, minus 13. Now we're down to 62, okay? So June has 30, right? Wait, I have hopped way ahead. April, I think I know where I'm going with this is what I'm doing. April has 30, so you have 32 days left. May has 31, because remember they kind of take turns, as my grandson says. So you have 1 day left. So your maturity date of this loan is liable to be June 1. Okay, so see, that's pretty simple, pretty straightforward. You just need to look at a calendar, and you should be able to work that out. Okay, that's all I have on this one. If you guys have any questions, please feel free to reach out to me.